questions, you should always be a little suspicious, except for when, you know, sometimes you get, like when you're starting out, for instance, in this exam, very often, you get question 1, A, B, C. It might be, for instance, differentiate 3 completely independent functions, okay? And we group them together because we want you to do the same thing to all 3, even though they have nothing to do with each other, okay? However, when you've got a question like this, you've got some kind of information that's common and you're sort of building up, you should always be thinking, okay, they're usually trying to lead me down a particular direction to solving the question, okay? In fact, we could sort of, if we were being mean, right, and we wanted to see if you can do that sort of conceptual leap type thing, right? If we wanted to put this in a later section, we would just give you this question without the lead-in. Okay? Because the point of part 1, or part A, right, is to say, well look, here's some information, you solve that, that'll help you with the next part. Okay? So just keep that in your mind. Let's do part 1 together. Okay? Usually we call this alpha and beta, but it's all the same, it's just slightly different labels. Okay? So when we're working out m plus n, mn, and m squared plus n squared, all you need is your sum and product of roots. Okay, that's what we're doing here. Yeah. So let's start with the sum. The sum of the 2 roots. What's the result? Remember, what fraction is it? Minus b on a, right? So minus b would be positive 1, and a is also 1. So that's not too hard. Okay. Product of roots is c on a, right? Which is 3. Now, m squared plus n squared. Do you remember what's the trick that we use for this? Okay, you're going to need to remember this comes from, one of these has to be squared, right? Because you've got m squared and n squared. So the question is which one? It's probably going to be this one because they're separate, but then you have to compensate, right? So this is going to be m plus n all squared, but then it's got extra stuff. So you have to subtract 2mn. Yeah? Is this ringing a bell? Okay, so you got 1 squared minus 6, so this is minus 5. Okay, so far so good. Now when you're looking at this next part, they're asking you to construct a new quadratic equation which has roots alpha and beta, okay? And where alpha and beta are these 2 things, okay? So therefore, how do you go about this? Well, if you just want alpha and beta, you'd say that equation looks like this. This quadratic equation has roots alpha and beta, okay? However, of course, they give us more specific details on what alpha and beta are, so I'm going to need to bring those in and try and simplify out, okay? And in fact, the actual answer, this is what people were puzzling over, the actual answer has no m's or n's in it, it's just numbers, right? And it's just like, where did they come from, okay? So before I do that, I'm just going to factorize these 2. That's going to make it a little bit easier when I expand out and do my algebra. This is a common factor m, and this has a common factor n. Sorry. That's n minus n. Is that right? Yeah? Okay, good. So now when I bring this in here, okay, first let's just substitute. It will look gross, and it will get more gross when we expand it out. But we've got to try and remember, these numbers here are going to be useful to us later on. Alright? The question's just how. So here I've got x minus alpha. And this is x minus beta. Yep, just straight substitution. Now here, in order to get from this kind of thing, which is correct, just not simplified, up to connected to these, right, I've got to expand out. I've got to get these m's and these n's talking to each other and factorizing so that I can get it in some of these terms. Okay, so let's see what we can do. When I just do a straight expansion, which, before I do a straight expansion, I might have, say it again?
Is it expanded and sub?
Sub what in?
Like expand the topic.
Expand this bit?
And then sub.
Oh yeah, I see what you mean.
Amazing.
Yeah, okay, yeah. I mean, they'll lead us the same place.
Yeah, so like the expanding is...
Yeah. So we got here, what do we got? X squared minus alpha, this will be alpha plus beta, right? I think. Sum of alpha and beta. Plus alpha beta. Is that right? I skipped a step, because I'm going to get minus alpha x and minus beta x, so that's why they come together. Yeah, nods, slow, yes. Okay. Alright, good. Okay, now I'll put it in, because there's my alpha and my beta. So x squared minus the sum of these. Yeah? Sum. M minus n minus. That's alpha plus beta x, and now I have to take the product. Yeah? Okay. Okay, now this does, it's difficult, and don't ask me to try and say that sentence, because it's kind of like how much wood could a woodchuck chuck if a woodchuck could chuck wood. I'm not going to do it. But how are we gonna make this better, right? What I noticed first is I've got n minus n and I've got n minus m. Now there's going to be some factorizing I can do once I get things in the right order, right? So for instance, up the front here, to change this n minus m into an m minus n, they are terrible letters. A and B is so much better. What do I have to do? I have to take out a factor of minus 1, right? So minus n. See what I did there? Is that okay? All I meant to do was draw attention to what, anyway. Okay, same deal here, right? The m and the n are going to come together. So that's an x, right? M, n, okay? I can call this m minus n all squared if I take out a negative, right? So in fact, I might put my negative there, okay? And what I'm left with is m minus n all squared. Okay? Good so far? Here, what do I have? X squared minus, if I take out my factor of m minus n, what I'm left with is m minus n. So actually, it's just m minus n all squared. And what do I have over here? Minus m n. Okay, now I'm almost there, okay? Can you see this expansion and simplifying that kind of thing? What I'm trying to get to is things like this. This is useful to me, right? Because I know exactly what mn is. It has a numerical value, okay? So I can sub that out, almost, okay? But then I'm left with these m minus n all squareds, okay? Which don't appear on our list, but we can make them appear on our list, right? How do you get m minus n all squared?
M squared plus n squared minus something.
Okay, when you expand this, right? This is m squared plus n squared
We have to add m.
minus 2mn, right?
Yeah.
You see it? Okay. So therefore this is, that's minus 5, right? Minus 2mn. This again, I'm doing it again, right? So this is minus 6, right? Yep. Yeah, okay. So now I have all my pieces, okay? Down here I can say that's going to be x squared plus 11x. Plus 11, yep. And then here I need to take the product. So that's going to be plus 33, yep. Ta-da.